Hello, this is Dr. Y.S. Rao, Dean Academics and Research, Sardar Patel Institute of Technology, Founder Director, Go-Green Technologies Private Limited. We have two centers. One is at Mumbai, where our head office is there, incubated in Bhavan's campus, specifically in Idea Lab, where all research and development is happening at Mumbai. At Vellanki, which is located near Nandigama, Andhra Pradesh, Krishna district, where we have skill development center, meditation center, and the fabrication facility for electronic boards. We do provide internship programs for students who are interested in science and technology. At Vellanki, we also have provision for residential facility. At Mumbai, we also provide training programs majorly on manufacturing of the machines. Like any product, if you want to convert, you may require 3D printers, laser cutters, milling, etching, drilling, cutting, vinyl cutters. So all those manufacturing machines are available at Idea Lab. We provide the training at Mumbai Center. So these are all my associations. Government of India, Department of Science and Technology, Sardar Patel Technology Business Incubation Center has granted a fund for development of this product. So now this product is in manufacturing stage, IoT products, Internet of Things. Internet of Things is all about communication, computation, and sensing. Communication means how do you transfer the data? Do you transfer the data with wire, wireless, or fiber optic? Wired communication means it could be USB, it could be UART, it could be I2C, it could be CAN, and so on. Wireless communication means Bluetooth, Zigbee, Wi-Fi, RFID, GSM, and so on. Fiber optic is it's a converting electrical signal into a laser beam, and through fiber cable there will be a light emitting diode which will emit the light, which is a laser beam, and there is a detector at the end which will convert the light back to the electrical signal. So any of these three communications can be used. However, since we are talking about Internet of Things, so communication now preferred communication is wireless communication, that too Wi-Fi communication, so that you are not locally connected. Your design, your product, whatever you have designed, that product is communicating globally because internet is available globally. So your product will have a unique ID, the way you have an email. So anywhere in the world, anybody can communicate. Similarly, your product can communicate to anywhere in the world. Computation is the second component in Internet of Things. Computation means brain, the one which executes the program, CPU. But today they are not simple automation systems. Today the kind of computation we are expecting is smart device. Smart means like humans are smart, we expect even the devices to be smart. That kind of computation market is expecting. That means you have to execute millions of instructions per second. So, so smartness comes because of two things, software and sensors. Okay. The third component is the sensors. Why sensors are required in IoT? See, when you are talking about smartness, I already said, smartness means humans are smart because we have sensors. So similarly, device is smart because of the sensors. Second thing is when you are saying smartness, that means smartness means its behavior is not just a simple automation. Its behavior, the way a human behaves. If you are expecting that kind of a human thinking, then you require huge amount of data to be processed so that the decision a machine can take is like a matured person. A child doesn't have huge database because the child is still in a learning stage. So the decisions are like a sometimes may be correct, sometimes may be wrong. Same thing happens in machine. If you have a less amount of data, then the machine decision might not be accurate. But if you have like a matured person, if you have a huge amount of data, real time data, correct data, then the decision taken by the machine is much, much better than a simple automated machine. So collecting the data, real time means natural time, means at this point of time, whatever is happening in the environment, I want to sense. So that kind of data, if you want to acquire, then you require the sensors. Sensors are the one which converts the physical parameter into electrical signal. So you can say applications could be robotics or it could be everywhere that we will discuss separately about the applications. In short, we say this is all about Internet of Things, about currently what we are manufacturing. About the Go-Green Technologies, already said, we are running a skill development center also, apart from our social activities. Since skill development is the one which is employable, so we believe whatever is this century demanding, right, the industry is demanding, we wish at least those things should be imparted in every student. And programming is mandatory irrespective of your branch, and that programming also not just a start and loops. It should be a professional, it should be industrial programming, and that too a programming. We are not talking about computer programming, we are talking about a programming which is a product programming, because products are everywhere, not the computers. So, what are the products? Mobile is a product, right? Your air conditioners, refrigerators, washing machines, two wheelers, four wheelers, drones. So, you name any product, there is a software and hardware. So, we are talking about the products, not the computer. This I have already spoken in my earlier videos. So, in this internship program, we believe if you if you do it at Mumbai, either physically or hybrid mode, or if you join our residential program at Wellanki or in the hybrid mode, what one should learn is first is to begin with user programming by using some visual language through graphics because we are not sure how good you are in particularly concepts about the product. We are not talking about computer, it's about the product. So how to program a product, that's what we wish one should know. So 1 week you have to spend on GUI based programming, what we also have called as a QU board. We have some board. Let's start with. We don't encourage to use this language or this hardware more than 1 week. However, if you have a school children below 10th standard, we wish this course should go at least 1 month. This next one is about embedded C program using our own designed RoboKit, which is having IoT facility, means it has the ability to communicate to the internet also. This robot we have specially designed for students so that sensors communication, mean Bluetooth also, Wi-Fi also is there, plus high-end computation. That kind of features are there where you can also change the CPU. To begin with, we are using embedded C program, which is designed by us. What do you mean by designed by us? Means the ready-made programs which you get on the internet, as it is, they doesn't work. You have to at least customize. You should know how to customize the program. So one should be a very good programmer in embedded C. That's what is the products are demanding. But don't think that Arduino boards, Raspberry Pi boards is the program because they are general purpose boards worldwide. They are supplied by some Chinese companies in low cost. However, no product, no patent you can get by using those boards. Actually, they are banned in higher education. The third module one should do is you are supposed to write some mathematical equations. It could be any simple maths, physics, or for some extent any chemistry. Means your 10th, 12th standard maths, you take the books and those equations try to put it in the program, not in computer. Again, I said it's an IoT kit. And then see how your maths, your mathematical models, when you execute, what kind of variables they are generating. It is so important to understand the maths because, like I said, today when we are saying artificial intelligence, right, machine learning, data science, this is all about nothing but maths. So, mm, high-end mathematics you are supposed to implement in a device. That's what is the whole world is talking about AI, ML, or data science. Our specialization is we don't end up with only computer simulations. Actually, we don't use also computer simulations. We put all these models in a device because our job itself is product manufacturing. So that's we expect again at least 1 week one should spend in implementing the mathematical models by using embedded C and eventually Python language. Then the fourth module, what we expect is IoT technologies. It's IoT, like I said, the communication, computation, and sensing. This itself is a huge subject, but quickly you need to understand what are the layers of the Internet of Things. There may be world standards are there. Some companies came together and set the standards like 5-layer architecture, 7-layer architecture. But The basic architecture is three layer. So you need to understand what is the first layer called perception layer. Second layer is communication protocols. Third layer is the application layer. At least you need to understand what are the protocols which are used in these layers. And the first layer is all about sensing and computation. That's what we actually offer also one full course on how to use sensors, types of sensors, how to program them. The next module is about applications. You can come up with your own ideas. You can also propose your own ideas. However, since we have a facility in a village where a big campus, we have installed concentrated solar power, PV installation, agriculture models because they occupy a lot of space. So since this is not possible in cities, cosmopolitan cities, this we have done at Wellanki. So there in real time, you can implement your mathematical model, data analysis, and some predictive algorithms. Similarly, you can also do the same things in hydroponics, drip irrigation, and water management because these are the things badly required for the society. If you are interested in a research internship program instead of the skill development programs, we recommend if you are only a final year student and if you have your own ideas, let us propose. Case to case, definitely we will discuss about how to convert your ideas into product. There we require special attention. But however, my experience last 30 years is unless you know the above things, that's the software, hardware, design, and protocols, it's very difficult of doing the converting the ideas into product because half knowledge is very dangerous. If you are having absolutely no knowledge, excellent, no problem, we will take care. Or if you have a maturity in the technology, excellent, we will be happy to work with you. But with half knowledge, if you join and if you say research internship, then it's a horrible for both of us because we don't understand what we are saying. Okay, we believe, like I was saying, do it yourself concept because skills are not a group activity, skills is individual activity. Every one of you should be employable, and since this is a profession, at least 50 years of your career, right, till you are on this earth, you can practice your profession. So you should acquire some, right, lifelong skills and so also ability to learn lifelong. Those are also how to impart. So we have made some product called single board computer, which has some IoT components. We wish one should start from scratch, design, soldering, fabricating, troubleshooting, application development. So that we have designed our own product. This is the only thing we wish at least you buy this some around 5,000 rupees components. The next one is about 3D modeling. Why 3D modeling has become important? The reason is it's not about only the hardware and software development. If you go for applications, probably you may require some 3D objects or 2D objects. Since at Mumbai Idea Lab, we have the facility for 3D printers, laser cutters, all those manufacturing equipment. If you model it, then we can get it done, the manufacturing of your models. So there is a free online software is there. called Fusion 365 or tinkering software. One should, of course, it is online, free. You should register and start practicing on the 3D objects. We'll also train you some extent how to design your own product. So, if you get an opportunity, please do visit Mumbai also. There, we will teach you about the product manufacturing process in Idea Lab. However, we do not have residential facility at Mumbai. We can provide you some low cost within the institute, like a dormitory type of accommodation. It's not only just developing a product, right? Equal amount of energy goes in writing a paper at a national or international conferences, writing the papers to journals, and also writing a patent. One should also know these things because the industry is majorly service oriented industry. 70% of the jobs in service sector. So one should know content development, presentation, communication skills. We also believe train the trainer because see, unless you become a trainer, you understand what are the skills are required. So we provide the opportunity wherever one school children do visit our center, we'll give you opportunity to train them, right? Or if you wish, you can also visit various institutes or industry. We will fund you for your visit and give a demonstration about the products that will give an opportunity how to be a professional trainer. These are the leadership qualities. Because when you expect the jobs of right managerial positions, not just a developer, then you have to improve your personality. So that we will provide the opportunity. Since it's a at Velanki, this is a residential campus, and the purpose of providing this campus, locating this campus in a small village, the reason is right. You need to understand the societal requirements, right? Particularly understand because we are really doubtful how many people understand what is societal problems, agriculture problems, water problems, environmental problems. So, sitting in cities, sitting in air conditioned cabins, you cannot visualize what are the real products, how these products works in the real environment. So one should install these things in with a normal atmosphere, real conditions, then you will see how do they work. We strongly believe first, right, everything, right, self-service, do it yourself. Nobody is a servant, it's a dignity. So whether it is a cleaning, cooking, plantation, meditation, right, food preparation, right, sports, do it yourself. Europe, US, by default, this culture is there. We do have culture in India historically, but somehow we have lost during this Britishers' rule because we were slaves, right? That slave culture is still continued, unfortunately. That should we come out of it and nobody is a slave, everybody is a master. So small charges are there because of this accommodation and maintenance of the campus. So we charge 150 rupees per day per student. And you have to take care of the cost for your food. We provide it, but the cost is as per actual. All right, this is about the internship program. Currently, we are offering at both the places. The major product currently we are manufacturing and selling is IoT lab setup. So this I will separately discuss in technical discussion. So These are the products. Okay, so today's session is all about the first course, like I explained in my previous talks, a QU bot. Why QU bot is when we program this device, we are using a visual program, graphics, no high level language or low level language. The highest possible language is a visual programming. In my previous talk, I explained what are the components are there on the board. Particularly, you can see there is a CPU, 40-pin CPU, which is a brain where the program is loaded on this chip, whatever your algorithm may be, and executed. Once it's executed, then it may control two motors, DC motors, three LEDs, one buzzer, one LCD. And it also has some inputs like sensors, right? You can see this infrared sensor, front sensor, left sensor, right sensor. And to measure the speed of the wheels, you have backside, again, left and right sensors also there. Three switches are provided if you want to give any inputs through switches. And one reset switch is to restart the program. So these are some features which are there. Just to indicate the data, you can use this LCD, text LCD, where you can display the data 16 characters in one line. Such type of lines are two. It is called 16 by 2 LCD. You can also use this USB to transfer the data to the computer. So you can display the data on your computer screen, what is called communication port or UART. For school children, we are offering 7th standard onwards, but based on your level of understanding up to engineering, you, are, you can work in the advanced topics like I was telling, Internet of Things, artificial intelligence, applications, protocols, and so on. We believe the first course everybody should know is knowing about the sensors and the actuators, out means in short input and output devices. The second course is programming. So today we are talking about the programming, but this programming is at a higher level. Higher level means by using visual programming language. Third is you should develop the applications. All right, so these are the professional skills I explained in my previous video also. To begin with, QU Robo, that is using visual language. Second is program by using embedded C or Python, which this robot we are manufacturing, and do it yourself. Means we should buy those components, make it, practice at your home for months. Then I'm sure you will be one day a professional in this domain. And you also develop your own products. If you are interested in knowing about computer installation hardware, this is the course. Installation of the operating system and the device drivers is the course. And then personality development, communication, presentation, spoken English, and some tools, right, for documentation. These are the professional skills. Either you do it or you can join at the center. Like I already said, cleaning is next to godliness. Do it yourself. So this board consists of various components which I described in my last session. Uh, I was telling first is about the CPU, then about the motors, then sensors, outputs like LCD, and communication. So these components we have discussed extensively in my previous video. What components are there? So total 28 components are there on the board. So go through the manual, and I explained in my last video also how many components are there, and locate them first. Looking at the figure, locate where is that sensor, where is that input, where is the output, where is the motors, where is the LCD, where is the serial port, where is the on off switch, every component. So whatever is mentioned, all these, right, components, 24 components, where they are, first locate them and try to understand as mentioned in the manual. And we will discuss about it. One should discuss about it once you locate them reading the manual. All right, so I also discussed about how to install the software. Two softwares you have to install. One is the driver, then second is the about the uh, QBV lab software, Visual Lab software itself. Driver means how the robot will be recognized by your computer when you connect it to the USB port. That software is there in CH341 serial Windows software. You open this folder and there is a executable file. Just double click it, install it. That is one way of doing. If your computer is not recognizing means like last time I have mentioned, it in the ports, this ports should window should appear in your device manager. I will show you once again. And if that is not appearing, that means you are not connected properly, you are not switched on the power supply or USB cable problem, whatever. Once this is recognized, then this COM port, right, USB to COM port, this should appear. If this is not appearing, that means your software installation of the CH340, some problem is there. In that case, use this CP210 driver software. But this software, you cannot double click it. There is no executable file here. What you should do is you should right click on this USB serial port which is not properly installed. Properly not installed means the number won't appear. Then right click on it, there update driver, select update driver. Then say browse driver. Once it says browse driver, provide the path for this CP210 driver. Then it will automatically detect this number will appear. That is, or here also, no, in this notification window also, it will show you some USB to serial port is installed. Some beep sound also will come when you connect your hardware. That completes the driver installation. Once the driver is installed, then this setup file is there, QBV lab software setup. Install this setup software. There's nothing is there, just you have to keep on clicking left button of the mouse. These are the two softwares you have to install. Once you install it, then on your screen, on your screen, this QU bot Visual Lab, this Q logo will appear on your screen. That means the software, Visual Lab software you have installed correctly, and on your maybe laptop or computer, this desktop, this icon should be there. Once you install, right, just double click this icon, QU bot Visual Lab, then this screen will appear. In my previous video, I explained about this video. What are the tools and components which are available, particularly how to load a file, how to save a file, how to rename a file. That is there in the first part, file. Second is about the quickly shortcuts, right? New. New means new program. This is where you writing a program, but not typing these blocks, because this is all about visual graphics. So that means your program is nothing but a box. You have to drag it. Press the left button of the mouse, drag it and drop it here. That's all. Then that button, see what is this box? Box represents a program. In the back end, it has a piece of code which is not visible to you. You only drag and drop a box, but in the back end, this is called coders. So people have now come up with coder blocks. That means instead of type the code, the block represents the code. You drag it, that means code is dragged and dropped in your workspace. So this is your, whatever the blocks you draw it here, this is the program which will be loaded into the hardware. So this is your programming blocks, which I explained in my last talk, components. Once you want to compile, then you say program. If it doesn't have any problems, then it will say ready. And in this here, it will show programming is done. 10th button will indicate whether your USB to the hardware is correctly connected or not. Green means correctly connected, red means connection is not established, like that. You just verify the status. Whenever you click a button, any of these three buttons, then here the attributes window will appear. By default, it won't be there, but if you select any of these things, the attributes will be appear here. Then you have a choice of changing the values. Program means starting code, means the moment if you say new, these three boxes will appear. That's the programming. What does it mean? These three boxes means start, end, in between you can drag and drop some blocks. Start means what? It will initialize LCD. It's your choice. If you say no, it won't initialize LCD. Then serial port, right? Serial port has to be there because you want to transfer the data program. So that speed, baud rate, you can see 57,600, or you can also change the speed. So two things, initializations are done in the start block. By default, every program has this block, starting of the program, where first instruction of your program is coming from the start. Then in between, drag component here. That means drag these components here, where the code is your choice. But however, once your completion of the code execution is done, then it go to the end block. End block means now it will terminate. Termination of the program, infinite loop. So termination means three beeps will appear and it will stop executing the program. So this is how your programming window works. Like I said in the previous video also, go through what are the components. So total 10 components are there in this software window, that is your visual lab software. Every component, just read it, the features, and practice them. That is the first part. Block by block also, you should select the block, drag it into your workspace, means where here, and then select the attributes. If the moment if you click it, this attribute window will appear. Then you see how many options are there for every block. For example, if you select a LED here, then it will show the attributes. It will give you option. Do you want to switch on the LED? Do you want to switch off the LED? Or do you want to do the opposite behavior of the previous state? Toggle. Toggle means previously if it is on, now it will be off. Or previously it is off, now it will be on. So three choices it will give. So what do you want to do? Whatever is the choice you select it here, it will appear here. And once you say program, then the program is transferred to the CPU. Alright, so we wish at least all these blocks you should practice it. If not, practice means just drag it, drop it, see the attributes. Because programming anyhow will teach you separately. Okay, so 5 types of blocks are there. If you carefully look at these components, yellow color, this is called output blocks. Means we are sending the data to the outside world. So what are the output blocks? Buzzer, LED, LCD, motor, UART. They're all sending the data from the CPU to the outside world. Operational blocks, which are in blue color. So operational block means you can define some variables, or you can delay your program, or you can define some values. You want to pass some values, or you want to have some counter operation. So those are all operational blocks. This green color is all called conditional blocks. Means you want to execute the program based on the condition. Means unless the condition is satisfied, the code won't be executed. So that's why you can see everywhere if. If means if what? Then in the bracket some condition. If that condition is satisfied, then only execute the code. Otherwise, execute the next line, not the same line. So if you want to verify any, for example, if any obstacle is there or not, then what do you do? If IR sensor is high, then that means some obstacle is there. Then what do you want to do? Stop the motor. If IR sensor is low, that means if no obstacle is there, then you want to on the motor. So you want to on the motor, off the motor. The decision is taken by using if condition. And what is the condition? This IR sensor. Similarly, you can have conditions for switches, UART, LDR, and so on. So all these are if conditions, means conditional execution. Red color is loop. Loop means what? Your program is continuously in loop. Means again and again and again you want to execute whatever you mentioned in the loop, right? So that is called loop. Start and end blocks. Start and end blocks, we already said. This is your start block. This is your end block, which is in a purple color. But however, every program requires start and end. Start will initialize LCD and serial communication. End will terminate the program with 3 beeps. Okay, so like I said, buzzer will switch on or switch off or toggle the buzzer. It's a digital. LED, 3 LEDs are there on your board. LED 1, LED 2, LED 3. If you select them, the attributes window where you can say on, off, toggle. LCD is also output component where you can display the text and numbers. How many? 16 characters, 2 lines. There is a 2 motors are there, DC motors. You can control the speed, you can make them on, you can make them off, you can change the direction, forward direction, reverse direction, like that. That's output. And the final output is a serial communication. Serially, if you want to transfer the data, instead of displaying on LCD, you can also display the data on your computer terminal. What are the operational blocks? Operational blocks are in blue color. So these are all variables, right? Some constant, some numbers. If you want to assign, you want to pass some data, you can use this variable. Let's say I want to set a value 50, 100, 200, means I want to count something, right? So that is a variable. Delay means you want your CPU to wait for some time. Kill the time, do nothing. That's called delay. Like say for example, on time means after that time you want to switch on the motor. Off time means after that time you want to switch off the motor. So that is called delay between on and off. How much delay you want? The unit is microseconds, milliseconds, and seconds. So you can choose by how much delay you want to delay it. Then variable operators. You have operators, right? Math operators. Not all are available. It has its own limitations, this software. We will use, that's why after this course, we will use embedded C and Python. Here we have limited operators like addition, subtraction, multiplication, division. So if you want to use these operators, you can use it between the two variables or between variable and a constant. The constant is limited to 8-bit number. And counter. Counter means increment the value, decrement the value, counter operation. Because see, you want to count how many steps forward you want to go, how many steps backward you want to go, like that. Conditional statements, right? if instead of executing the program in sequential manner means what? One after another, one instruction after another, you want to execute the program. Instead of that, you want to split your code, right, in multiple functions. That function should be executed only if that condition is satisfied, otherwise no. So you want to have sort of a multi-conditional, multiple conditions, multiple tasks. However, that task should be executed when that condition is satisfied. For example, if the IR sensor, if obstacle is detected, stop the motor. Otherwise, on the motor. So how to split the code? That means on the motor is a one function, off the motor is the another function. Then you read first the sensor, IR sensor. Then you say if IR sensor is 1 means it has detected the obstacle. Then you will execute off the motor program. No, if IR sensor is 0, oh, no obstacle is there, then you say on the motor function. So how to split the code? So you can split the code by using these conditional statements. So you can use this if the condition is satisfied, then whatever is mentioned is executed. Otherwise, next instruction is executed. Else if means continuation of if, where you are saying else if means the earlier one is not done, okay, else if again you are saying if this condition is satisfied, execute the current code, otherwise go to the next. Else means what? Okay, in any case I do not have a choice, I am not verifying the condition, whatever is mentioned, execute it. And if means what? Okay, nothing is, no action is required, I am terminating, go to the below whatever is mentioned is end if statement, means I am terminating my if condition. Similarly, you can also have conditions for your sensors, not only variables. Variables means you define some numbers and you look for some numbers. But here, sensors, which sensors you are having? Infrared sensor, LDR sensor, right? Or TV remote sensor. So you mention the sensor and you read the sensor value and split the code. Do you want to execute or not? Okay. So in serial communication also you have if condition, so that when user is sending the data, based on the data you can take a decision. Do you want to move the vehicle forward, backward, reverse, all those things you can do it by using UART through computer communication. Later on this we also do it for Bluetooth and Wi-Fi devices also through serial communication. Same is applicable to switches and motors, because motor means actually motor is output device. Motor won't give any data, but here what we are looking for is a encoder, because motors are having left side, right side, two infrared encoders are there, infrared sensors are there. So they give you some counter, right? Some counter value, right? That counter value you can compare by how many steps the vehicle left wheel has moved, by how many steps the right wheel has moved. Okay, 5 steps, then stop, or 5 steps, go forward. So you can split the code for motors also based on the encoders. Encoders are the sensors. Then you have a while loop, infinite loop. The infinite loop could be conditional also. So in the bracket, you mention the condition. While while this condition is satisfied, then execute the code. Otherwise, be in the infinite, means continuously in the same loop. All right. Then your program in purple color, start. Start means initialize LCD and UART. You can set the attributes by clicking that, and end means it will terminate the program, means it will be infinite loop, means do nothing. CPU will do nothing, but it will give you 3 short beeps. So far whatever we have discussed is a revision of what we have discussed in my previous sessions. Now let's start programming. How do you do the programming? When you choose first is a new code, first say new, then your three blocks will appear, purple color, start, end, and a drag box. Use your mouse. For example, select one component, block, let's say LED. You left click on that LED block, drag it, drop it in your workspace. That's all. Workspace means where this drag box is there between start and end. That box will appear. That's the first step, what we called as a drag and drop component blocks. Whatever is there in your workspace is converted into actual program. So you have to drag the components into your workspace. After that, again click on the box because you want to set the attributes. For example, for a LED, what are the attributes? On, off, toggle. Three choices it will give. Number one. Number two, how many LEDs are there? Three LEDs are there. So then the option is which LED you want to make it on, which LED you want to make it off. If you want three different LEDs, then three boxes you have to drag it. Only one if you want to program it, just drag one block and make on off toggle. So every sensor, every device, if you want to program it, separately you have to drag it and drop it into your box. And left click, it will show the attributes. Once the drag and dropping means design of your program is done, then you have to simply click the button in the tool menu, say program. If you say program, you can see the bottom of the screen, this programming status will indicate and these blue color dots will indicate the program is transferred from the computer to the board by using your serially through USB cable. This green symbol indicates programming is happening and the red indicates it is doing nothing, programming is done. And also since you have an end block in the program, it may beep if once it's execute the program, it may show some short beeps. If you want to delete any code, right? Code means your blocks, then you right click, not left click, right click on the block, then you select the delete button on your menu and delete that block. Then, so adding, deleting is done with the help of the mouse, left button and right button. And attributes you can set by selecting the button. All right, so let's look at the uh, characteristics of a LED block. Drag it, drop it in your workspace. Left click on the LED block. The attributes will appear. Now these attributes, how many options it will give you? It is saying three LEDs are there. Which LED you want to use for that block? If you want one more LED, then again you have to drop another box. Since now you have selected on one block, that one block is what? Or you want LED 1, LED 2, LED 3. Again you have, what do you want? LED on, LED off, or toggle that LED. So three options for each LED. So select the LED, select the output state. That's all. Then once you program, this code is, these attributes are converted into reality. Then you will see physically that particular LED on, off, toggle. Toggle means opposite to previous case. And like I was saying that this is the space where you have to drag it and drop it, your uh, the blocks. But every program consists of one start and one end. In start, if you select, it says LED initialization yes or no. If you are not using, say no. But serial communication, say yes because you will be using that. Then the code, if you select the code block here, left click, then like LED, it will give you these many options. End is you don't need to change anything, only it will terminate the program by three short beeps. Okay, so let's load a program, right? Uh, or design a program, how it looks like. To begin with, purple color start and end, and in between that where the drag component is there, you add your blocks. What are the blocks? Just for try it. First of all, only two components you have used, LED, but and delay. How many places you have placed? One here, then delay, LED, LED, delay, LED, LED, delay, LED. Okay. Now, what is the behavior of the program? Means you left click this button. In the attributes, what you have selected, you want LED 1 to be on. That's what you have to select it. Then you said you selected on the delay block. There, what is the value you have set? 2000, and you what is the unit you have selected? You are supposed to select, let's say, milliseconds. Means 2000 milliseconds. This LED will be on. After that, what you are saying, one more block of LED, you are saying same LED you are selecting, but attribute you are saying off. So this LED will be off after 2000 milliseconds. Then one more block you have selected saying that LED 2 you want to make it on. This time the delay you want only 1000 milliseconds. LED 2 will be on. Then you said LED 2 is off. Okay, then you have selected LED 3, then you said LED on, then delay of 500 milliseconds, then you said LED 3 is off and terminate the program. So once you execute the program on your board, what kind of results you expect? First, LED 1 will be on. You will notice with your watch 2000 milliseconds, right? 1000 milliseconds means 1 second. So 2000 milliseconds means 2 seconds. This LED 1 will be on. Then the same LED will be off after 2 seconds. Second LED will be on for 1 second. Then second LED will be off. And then immediately third LED will be on. For half a second, third LED will be off, on, and after that it will be off and end. That's all. So three LEDs with a delay of 2 seconds, 1 second, half second will be on and off. You should try this. Then you will understand what do you mean by code block, what do you mean by attributes, and what do you mean by sequence. Sequence means why first LED will be on, then only second, then only third, because the way you have placed them in the code, right? The flow of your program. So it's a sequential programming, right? The way you place in this block, in that manner only the program is executed. So this is what you need to understand. How to, first of all, write a code, then how to choose your instructions, what is called as a task, then which task should be executed when, right? The sequence, right? First one, second one, third one, which one you want to execute first, after that next. The sequence you have to choose. That is the flow of your program. Here also, like I said, you can have a conditional execution. Means again, this entire code you want to split into different tasks, saying that if this condition is satisfied, then only execute this piece of code. Otherwise, no, execute the next level of the code. So that is also you should understand what do you mean by splitting the program. So to begin with, these are the basic minimum concepts one should learn. All right. So that's all for the day. Thank you. And I expect you should practice it. Quickly, I will show you on the code also. What do you mean by code blocks? So this is, we already discussed, right? Let's see also about the device manager once again. Whenever you connect the board to your USB of the computer, you can see three short beeps first, right? uh, the program will execute through with the help of the speaker. You will find some LEDs, right, on your PCB, which is generally blue LED, indicates the board is getting charged. Press the on off switch, which is very close to your USB connector, right? On your computer also, it should say detected through some sound. On your board also, this red LED will be on, saying that the power is on. Okay, that's the indication. Okay, so then let's see how to verify your board is recognized or not. Go to search, type device manager. On your device manager, expand the ports. Here you should say USB to serial CH340 in bracket some number. If this is showing, that means your board is recognized. Otherwise, whatever I mentioned here, the software CH341 serial Windows, you install it. Then this should appear. Some computers, this software, if it is not working, then what you do is whatever some number it shows here, not the number, some yellow color serial, USB serial, in bracket it won't show the number, some yellow color symbol, exclamation or something like that, it will show like that. Then what you do is right click your mouse, say update driver, then say browse my computer, don't say search automatically, say browse my computer. Then which path you should provide? The path should be wherever this software is there, this folder. Show that, go to that folder, expand this. The first, let me show you how to expand it. Just right, I will double click the CP210. Okay, extract this folder. First, do this extraction. Now you see this CP210, this fellow is expanded. But here there is no installation software. It is just a no driver files. So you cannot double click here. What you should do is go to device manager. Here browse. Right? I repeat again. So what you should do, whichever is not properly installed, right click, update driver, then say browse my computer, provide the path. So where is this path? For example, in my desktop, right, somewhere I have copied this, right, say Idea Lab, Robo, somewhere, right, QU bot. In this, you can see CP210. So this folder, you say okay, then next, that's all, best driver, whatever is installed, then this fellow, the number will appear. This should work undoubtedly. That completes the device driver installation. This number should come. Once that is done, then like in last video I said, install this software, QBV Lab setup software. If you install it on your screen, this QU bot Visual Lab software icon will be there. Open this software. Whatever I was telling, this complete environment is available. This is where your program space is. Okay. If you say new, then this below will be there. Then left click your mouse, drag it, drop it here, and select the component. Then the attributes will appear here. Change the attributes, say program. The program will be transferred. Or I said first practice the existing programs. Say open. Then there is a folder called, right, QB Lab sample codes. So go to the first folder, LED folder. So all these 9 programs in this tutorial, I will explain maybe every program. Let's say first program, open. So what is this program? LED2 will be on. So if you download it, this code, simply say programming. You can see below screen, program is completed. On your board, if you notice, the LED2 will be on. But I'm saying first change the attributes. How to change the attribute? Select that button, right? You can see this arrow key, select. Then you will have options, right? What do you want to do? LED 2 on, off, or LED 3, LED 1 toggle. Change that. Let's say I want LED 3. Now you see LED 3 will appear. Now transfer the code. That program will be done. Okay, so that's the first program. Only single LED on or off. Let's see the second program. In the second program, you have single LED either on, give delay. Now see, when you select a delay block, what is that it is asking? The delay you want microseconds, milliseconds, or seconds. Then the value, you can type the value by how much delay you want, some number. So that number, let's say if I say 255, okay. So then the 255 will appear here, okay. If I say, let's say 256, but still it says 255. Why? Because the maximum number is between 0 to 255, 8-bit number it is taking. So take that as a numerical value for your delay. And again you are using LED to make it off. So this program is on the LED, delay of the LED, and program it, and you see whichever is the LED you have selected, that much time it should be on, then off, then terminate. Okay, that's the second program in LED. Let's look at the third program. In the third program is a slightly bigger one where you have taken all three LEDs. LED, first LED on, delay by 2000 milliseconds, then the same LED will be off. Second LED is on, delay by 1000 milliseconds, second LED will be off. Third LED will be on, delay by that much time, third LED will be off. However, now again you are not terminating here. You said while one. When you say while one, then see you said infinite loop. So in this infinite loop, you said be in this loop for this much time, means your three beeps won't appear till this period. Otherwise, once this code is executed, by default it is supposed to come to the end loop and say I am done, so three beeps. But in this case, what you have put one conditional, right? While one means true. So one you have already passed, right? When you say value, this value you already passed, say one. But here what is that you want to say? Delay by this much. You can also change, select the delay and change that. And terminate means once this is completed, then end infinite loop. This, because you have satisfied this condition, then it will come out of the loop and terminate. So conditional execution in an infinite loop, and three LEDs on and off with a delay of 2 seconds, 1 second, half a second. So this is about the third program. Let's look at the fourth program. In the fourth program, again you have a, right, in the initial case itself, you said while one, means you said infinite loop, but with a while one means true. If while one, if the condition is satisfied, then one is true, right? Then one LED is on, delay, and LED will be off, delay, and if, and terminate. So see the results, that whether this going to this loop or not, and once that loop is satisfied, it is coming out of the loop or not. Okay, this is about the fourth program. Fifth program, so I suggest you every program draw a your own, write it your own way by understanding this flow. You should be, first you should do not execute the program. First, looking at the program, first write the behavior on your notebook. Oh, this block will do this block will do this, or you modify the blocks, isn't it? And then write the flow on your notebook, and keep your notebook in your left hand, and through your right hand execute the program, and see whatever you thought the flow, the action is happening on the board or not. You change the action, see is it changing or not. So first, instead of writing new programs, use the existing program, try to change the attributes, whatever you have predicted is happening or not. So please understand first the significance of the components, significance of the attributes, and significance of the flow of execution of a program, in which step by step which instruction is executed first, which instruction is executed next, when it is terminating the program. So you should know starting, ending, in between the flow, right? So again, this is a program where it's executing in a while loop with some LED, but this time it's a toggle. Toggle means complement to the previous state with a delay of 100 millisecond. Anyhow, you can change the conditions. Okay, that's about the fifth program. Sixth is again, first LED 1, LED 3 will be on. Then you said while 1 condition. Then LED 1, 2, 3 will be on, or toggle. Toggle means opposite the previous stage, delay, and end the infinite loop, come out of it, terminate it. So draw this flow on your book, execute and verify. Change the sequence, try it, whatever you have predicted happening or not. So please repeatedly do the things again and again. One is the program, whatever is the program as it is executed. Second, change the attributes. Third, change the flow. Move these blocks here and there and see what is happening. Whatever you have predicted should happen. That is called logical thinking. See, the CPU always execute the programs one instruction at a time. So at any given point of time, which instruction should be executed, that you have to set, right? It won't do on its own. Whatever you have set the sequence, the same sequence the program is executed. And the attributes, the conditions, whatever you have created, it has to satisfy that. So please understand, since it's a graphical user interface, you can understand the flow. Later on, no graphics will be there, everything is a text. So whatever is the text you type it is the instruction, will execute. Slightly imagination will be difficult, but since it is a blocks, and moving the blocks, creating the blocks, deleting the blocks is simple. So the flow, try to understand, attributes, try to understand, behavior, try to understand. Okay, so this is sixth. In the seventh, right, you have, now you see, one is true infinite loop, but this time while is a condition, right? Switch cases, right? Now you can select the operators. For example, which operator you want, equal, right, not equal, right? Or do you want any logical operator, right? So that is, you can, and the value, what value you want to select, 0 or 1. So switch case means you have only either yes or no, right? So that switch case, if that is satisfied, then if that one happens, then LED one on. I mean, whatever you have mentioned will be executed. So this condition you have to satisfy in the while loop, and it is your choice. 0 on 0 you want to execute, or 1. So whatever you put it in the bracket, if that is true, then this loop will be executed. So both infinite loops, while loops were used. One is in the bracket without any choice. You said while 1 means true. Second is the condition, whatever you want to condition, switch on what? Equal, not equal, then it's 0 or 1. That you can select it and program it. Okay, so the same thing is, now you have a bigger program with all three LEDs with some delay in the infinite loop. it's not much difference like earlier one single while loop with a true condition. That is the eighth one. Okay, so again, it's even multiple LEDs, multiple times you have used, and in a while loop. All right, so practice first the LED program in this session extensively. Change the flow, use all three LEDs, create some conditional statements, particularly while loops. See the difference between while one, while condition, and use the switch case logical operators, change the operator and see what is the effect. So LED is a output device. So in the output components in this session, we have discussed about the LED as an output device and how to use this code flow selection of the blocks, dragging it here, changing the attributes, changing the sequence of the program is what you have to practice extensively for all three LEDs with all possible attributes, including while loops. In the next session, we will use some buzzer or some other output components. Thank you.